Tonight, we'll drift gently through the vast spiral of our home galaxy, the Milky Way. Above us, beyond the clouds and city lights, hundreds of billions of stars are quietly orbiting a common center, forming a structure so immense that light itself takes 100,000 years to cross it. Welcome to Get Sleepy Science. I'm so glad you found your way here tonight. Wherever you are right now, perhaps with the windows closed against the evening chill or with the gentle hum of nighttime settling around you, allow yourself to settle into this shared moment of stillness. We'll explore 100 remarkable truths about the Milky Way galaxy, from the supermassive black hole at its heart, to the spiral arms stretching across the cosmic void, to our own sun's quiet journey around the galactic center. Each fact a small light in the darkness, each discovery a step closer to understanding our place in the universe. If these calm stories from the cosmos help you breathe easier tonight, a gentle like and subscribe helps other stargazers find their way here too. It only takes a moment, but it means the universe to us. One sleepy soul at a time. There's no pressure at all. For now, just let your shoulders soften. Let your breathing fall into its own rhythm. Imagine yourself floating in the vast darkness between stars, where time moves differently, where the urgency of daily life dissolves into the patient turning of galaxies. There's nothing to solve tonight, nothing to remember, just stories drifting through the dark. Close your eyes and take a deep breath. Imagine you're lying in a small spacecraft, drifting gently through the endless night sky, moving without boundaries, without destination. Only the light of distant stars and absolute silence. Let go of all limits. Let your mind drift through the spiral arms of our galaxy. Now we begin. The Milky Way is a barred spiral galaxy, one of billions of galaxies scattered throughout the observable universe. Our galaxy earned its name from the ancient Greeks, who called the pale band of light stretching across the night sky Galaxias Kyklos, meaning milky circle. To the naked eye on a dark, clear night, away from city lights, the Milky Way appears as a soft, glowing river of light. What you're actually seeing is the combined glow of countless stars too distant and numerous to distinguish individually, all part of the same massive structure that contains our solar system. The main stellar disk of the Milky Way spans approximately 100,000 light-years across, though recent measurements using precise photometric methods estimate the visible disk at about 87,000 light-years in diameter. When including the vast dark matter halo that surrounds the galaxy, the total structure may extend nearly 2 million light-years across. This immense structure contains somewhere between 100 billion and 400 billion stars, each following its own orbital path around the galactic center. Our solar system resides in a minor spiral arm called the Orion Spur, or the Orion Cygnus Arm, located about 26,000 to 27,000 light-years from the galactic center. Think of the galaxy as a vast city. We live in a quiet suburb, not in the crowded downtown core, where stars are packed much more densely. This location offers advantages. The galactic center hosts violent processes, intense radiation, stellar collisions, and the gravitational chaos created by millions of stars orbiting close together. Our position in the suburbs provides relative calm, stable orbits and lower radiation levels, conditions that may have been essential for life to develop on Earth. We're far enough from danger, but close enough to witness the beauty of the galactic spiral stretched across our night sky. At the very heart of the Milky Way lies Sagittarius A star, a supermassive black hole with a mass approximately 4 million times that of our Sun. For decades, astronomers suspected its existence based on the rapid orbits of nearby stars, but direct evidence came in 2022 when the Event Horizon Telescope collaboration released the first image of Sagittarius A star. The image revealed a glowing ring of superheated gas and dust swirling around the black hole's event horizon. This wasn't the black hole itself, which emits no light, but rather the brilliant material spiraling toward oblivion, heated to millions of degrees by friction and gravitational compression. Sagittarius A star is relatively quiet compared to some supermassive black holes in other galaxies. It's not actively consuming large amounts of matter right now, which is fortunate for us. The Milky Way didn't form all at once. Current evidence suggests our galaxy assembled gradually over billions of years through mergers with smaller galaxies. Think of building a career, a relationship, or a skill. Transformation happens through countless small moments, invisible day to day, but undeniable over decades. The galaxy we see today is the result of patient, chaotic, beautiful accumulation. Stars formed, died, scattered their elements, and those elements became new stars. Smaller galaxies wandered too close and were absorbed. Even now, the Milky Way is in the process of consuming several dwarf galaxies, including the Sagittarius dwarf elliptical galaxy, which is being slowly torn apart by our galaxy's gravitational pull. Formation isn't a past event, it's ongoing, happening right now on timescales that dwarf human history. The Milky Way rotates, but not like a solid wheel. Different parts orbit the galactic center at different speeds, a phenomenon called differential rotation. At our sun's distance from the center, one complete orbit takes approximately 225 to 250 million years, called a cosmic year or galactic year. The last time our solar system was in this exact position, dinosaurs had just begun to emerge on Earth. In human terms, imagine your daily routine. You might return to the same coffee shop every morning, but your life changes dramatically between visits. The galaxy's rotation is real and constant, but on a time scale that makes geological epochs look brief. Since the Sun formed about 4.6 billion years ago, it has completed roughly 20 orbits around the Milky Way, 20 cosmic years of quiet, steady travel through space. The Milky Way's distinctive spiral shape is created by density waves, not by solid arms of stars. This is one of the most beautiful and counterintuitive concepts in galactic astronomy. Spiral arms don't rotate like solid spokes on a wheel. Instead, they're density waves, regions where stars and gas temporarily bunch together as they orbit, then spread apart again. Think of how a wave travels through a stadium during a sports game. People stand and sit in sequence, creating a moving wave, but each person stays in their seat. Similarly, stars move through spiral arms without being permanently stuck there. Your morning commute might feel different every day, but the pattern of traffic jams stays consistent. That's a density wave in action. The arms persist as patterns, even though individual stars flow through them. The Milky Way contains a prominent bar structure across its center, roughly 27,000 light-years long. This bar consists of densely packed stars and gas extending from the galactic nucleus. Not all spiral galaxies have bars. Some are pure spirals, but about 2/3 of spirals, including ours, are barred. The bar plays a crucial role in the galaxy's evolution. It acts like a conveyor belt, funneling gas from the outer regions toward the center, where it can trigger star formation. The bar also influences the orbits of stars, creating resonances that help maintain the spiral arms. Scientists believe the Milky Way's bar formed relatively recently in cosmic terms, perhaps within the last few billion years. It's a dynamic structure, and computer simulations suggest bars can form, dissolve, and reform over a galaxy's lifetime. Our galaxy is surrounded by a vast halo of dark matter, an invisible substance that doesn't emit, absorb, or reflect light. We can't see dark matter directly, but we know it exists because of its gravitational effects. The stars in the outer regions of the Milky Way orbit far faster than they should based on the visible matter alone. Without dark matter's additional gravity, these stars would fly off into intergalactic space. Current estimates suggest dark matter makes up about 85% of the Milky Way's total mass. The visible stars, gas, and dust we can observe account for only a small fraction. It's as if the galaxy you see is just the tip of an enormous iceberg, with the vast majority of its mass hidden from view. Dark matter remains one of the deepest mysteries in modern physics. The Milky Way has several major spiral arms, though the exact number and structure remain subjects of active research. The two primary arms are the Perseus arm and the Scutum Centaurus arm. Between these major arms lie smaller structures, including the Orion Spur, where our solar system resides. Think of a freeway system in a large city, major highways with smaller access roads branching off. Recent data from the Gaia Space Telescope, which has precisely measured the positions and motions of over 1 billion stars, has helped refine our understanding of the galactic structure. But mapping the Milky Way from within is challenging, like trying to draw a map of a forest while standing among the trees. Every new telescope, every new survey, adds detail to our understanding of the spiral pattern we call home. Every atom of carbon in your body was forged inside a dying star billions of years ago. The iron in your blood, the calcium in your bones, the oxygen you breathe, all created in stellar furnaces and scattered across the galaxy when those stars exploded as supernovae. You are, quite literally, made of stardust. This isn't poetry, it's verified astrophysics. When the universe began 13.8 billion years ago, only hydrogen, helium, and trace amounts of lithium existed. Every heavier element, everything in the periodic table from carbon to uranium, was synthesized inside stars through nuclear fusion or in the violent explosions that mark their deaths. The Milky Way isn't a distant backdrop to your life. It's the factory that built the raw materials of your existence. You carry within you the history of stellar evolution. The Milky Way and its neighbor, the Andromeda Galaxy, are moving toward each other at about 110 kilometers per second. For decades, astronomers predicted a certain collision in about 4 billion years. However, recent research published in 2025 suggests the outcome is less certain. There may be only a 50% chance of collision within the next 10 billion years. Just as two people orbiting busy lives might pass close by without fully merging, these galaxies may perform a cosmic dance that doesn't end in collision. Timescale changes everything. What seems inevitable on human scales becomes uncertain on cosmic scales. If they do eventually meet, the two galaxies will pass through each other gracefully, their mutual gravity warping and stretching both structures, possibly merging into a single, larger elliptical galaxy over billions of years. By then, our Sun will be nearing the end of its life. The Milky Way's disk is incredibly thin relative to its diameter. If you scaled the galaxy down to the size of a DVD, the disk would be about as thick as a sheet of paper. Most of the galaxies, stars, gas, and dust reside in this flat disk, which is roughly 2,000 light-years thick near the Sun's location. This thin structure is the result of rotation and angular momentum. When the galaxy formed, the rotating cloud of gas and dust collapsed along the axis of rotation, settling into a flat disk, just as pizza dough spreads flat when spun. The disk isn't perfectly flat. It has warps and ripples, possibly caused by gravitational interactions with smaller galaxies passing nearby. But overall, the Milky Way maintains its elegant, thin spiral structure. The galactic center is shrouded in thick clouds of dust that block visible light, making it impossible to see Sagittarius A star with optical telescopes. Imagine trying to see through a thick fog or through a wall. Dust particles, though tiny, are extremely effective at absorbing and scattering visible light. Fortunately, longer wavelengths like infrared and radio waves can penetrate the dust. Radio telescopes and infrared observatories allow us to peer through the obscuring material and study the galactic center. The James Webb Space Telescope, launched in 2021 and operational since 2022, has been providing unprecedented infrared views of the galactic center, revealing stars, gas clouds, and structures previously hidden. Without these longer wavelengths, the heart of our own galaxy would remain forever invisible to us, a mystery locked behind curtains of dust. The Milky Way contains vast regions of cold molecular clouds where new stars are born. These stellar nurseries are dense, dark, and cold, with temperatures just a few degrees above absolute zero. Within these clouds, gravity slowly pulls gas and dust together, forming clumps that grow denser over millions of years. When a clump becomes dense and hot enough, nuclear fusion ignites in its core, and a new star is born. The Milky Way forms roughly 1 to 3 new stars per year, a modest rate compared to some younger, more active galaxies. But over billions of years, this steady production has created the hundreds of billions of stars we see today. Star formation isn't just history, it's happening right now, in clouds scattered throughout the galactic disk, invisible to the naked eye, but revealed by infrared and radio telescopes. The Milky Way's supermassive black hole, Sagittarius A star, is about 27,000 light-years from Earth. To put this in perspective, if you could drive a car at highway speed, about 60 miles per hour, toward the galactic center, the journey would take roughly 300 billion years. Light itself, traveling at 186,000 miles per second, takes 27,000 years to reach us. When we observe Sagittarius A star today, we're seeing it as it was when Neanderthals still walked the Earth. This distance protects us. If we were much closer, the intense radiation, tidal forces, and gravitational chaos near the black hole would make life impossible. Our location in the galactic suburbs provides safety and stability. We're close enough to orbit the center and call this galaxy home, but far enough to enjoy the calm. The Milky Way is part of a larger structure called the Local Group, a collection of more than 80 galaxies bound together by gravity. The Local Group spans about 10 million light-years and is dominated by 3 large spirals: the Milky Way, Andromeda, and Triangulum. The rest are smaller dwarf galaxies, some containing only a few million stars. These galaxies orbit around their larger neighbors, sometimes merging with them. The Local Group itself is part of an even larger structure called the Laniakea supercluster, a gravitationally bound collection of galaxy groups and clusters spanning 520 million light-years. We exist in layers of cosmic structure: planet, solar system, galaxy, local group, supercluster, each nested within the next. Like Russian dolls extending outward into the vast universe, we're part of something incomprehensibly large. The stars we see in the night sky are overwhelmingly part of the Milky Way. With few exceptions, every star visible to the naked eye is a member of our galaxy, relatively close neighbors on cosmic scales. The most distant star you can see without a telescope is V762 Cassiopeiae, roughly 16,000 light-years away, still well within the Milky Way's disk. Even the brightest stars are local. Sirius, the brightest star in our night sky, is only 8.6 light-years away. Betelgeuse, a red supergiant nearing the end of its life, lies about 650 light-years distant. Andromeda, the closest large galaxy, is 2.5 million light-years away and appears as a faint smudge, not individual stars. The sky you see on a clear night is your immediate galactic neighborhood, a tiny sample of the Milky Way's vastness. The Milky Way's disk contains different populations of stars with different ages and compositions. Population 1 stars, found in the disk and spiral arms, are relatively young, metal-rich stars like the Sunday. Metal in astronomy means any element heavier than hydrogen and helium. Population 2 stars, found in the galactic halo and globular clusters, are much older and metal-poor. formed when the galaxy was young and fewer heavy elements existed. By studying these stellar populations, astronomers can piece together the Milky Way's history. The oldest stars in the galaxy are roughly 13 billion years old, formed not long after the universe itself. These ancient stars have witnessed the entire history of the galaxy, silently orbiting the center through countless cosmic years, survivors of an earlier epoch. Globular clusters are dense, spherical collections of stars that orbit the Milky Way. The galaxy hosts over 150 known globular clusters, each containing tens of thousands to millions of stars, packed into a region only a few dozen light-years across. If you lived on a planet in a globular cluster, the night sky would be spectacular. Thousands of stars close enough to cast shadows and illuminate the night. Globular clusters are ancient, typically over 10 billion years old, and they orbit in the galactic halo rather than the disk. They're like fossils, preserving information about the early galaxy. By studying their ages, compositions, and orbits, astronomers learn how the Milky Way formed and evolved. These clusters are survivors, relics of the galaxy's youth, still bound together by gravity after all these billions of years. The Milky Way contains vast amounts of gas and dust, the raw materials for future star formation. About 10 to 15% of the galaxy's visible mass is interstellar material, gas clouds composed primarily of hydrogen and helium, with trace amounts of heavier elements. This material isn't uniformly distributed. It's concentrated in the spiral arms, particularly in giant molecular clouds, the densest and coldest regions. These clouds are where stars form. As stars age and die, they return material to the interstellar medium through stellar winds and supernova explosions, enriching the gas with heavy elements created in their cores. This cycle, gas to stars to gas, has repeated countless times over the galaxy's history. The matter making up your body has likely cycled through multiple generations of stars before becoming part of Earth. The Milky Way is moving through space at incredible speeds. Our galaxy rotates, but it's also falling toward the center of the local group, which itself moves through the larger Virgo supercluster. When you account for all these motions, the Milky Way is traveling through space at roughly 600 kilometers per second relative to the cosmic microwave background. The faint afterglow of the Big Bang, that's over 1.3 million miles per hour. Yet you feel nothing. There's no sensation of motion because everything around you, the air, the ground, the entire planet, moves together. Just as airplane passengers don't feel the plane's speed when flying smoothly at cruising altitude, we don't feel the galaxy's motion. We're part of a vast, swift current in the cosmic ocean, carried along without resistance or awareness. The Milky Way's spiral arms are not permanent structures. Computer simulations show that spiral arms are transient features, forming, dissolving, and reforming over hundreds of millions of years. What we see today is a snapshot, a single frame in a movie billions of years long. The density waves that create the arms move at different speeds than the stars themselves. Stars enter an arm, slow down as they pass through the denser region, then speed up again as they exit. Like cars entering and leaving a traffic jam, the arms persist because new stars are constantly entering while others leave. This dynamic nature means the Milky Way's appearance changes slowly over time. If you could watch a time-lapse spanning hundreds of millions of years, you'd see the spiral pattern shift and evolve, almost breathing. The sun's motion through the galaxy isn't a simple circle. Our solar system bobs up and down relative to the galactic plane as it orbits, crossing through the midplane roughly every 30 million years. Imagine a horse on a carousel. It moves in a circle, but also up and down. The sun does something similar, oscillating above and below the galactic disk as it makes its 225 million year orbit. Some scientists have speculated that these oscillations might correlate with periods of increased comet impacts on Earth. As the solar system passes through denser regions of the galactic disk, where gravitational perturbations could disturb the Oort cloud. The evidence remains debated, but it's a reminder that our position in the galaxy isn't static. We're constantly moving through different environments over time. The Milky Way's magnetic field threads through the galaxy, influencing the motion of charged particles and playing a role in star formation. This field is incredibly weak by terrestrial standards, about 1,000,000 times weaker than Earth's magnetic field, but it extends across vast distances, making it cosmologically significant. The magnetic field is tangled and complex, shaped by the galaxy's rotation, supernova explosions, and turbulence in the interstellar gas. It helps regulate star formation by providing support against gravitational collapse in molecular clouds, and it channels cosmic rays, high-energy particles that stream through space at nearly the speed of light. Mapping the Milky Way's magnetic field is challenging, requiring polarization measurements of starlight and radio emissions. But each new observation adds detail to our understanding of the invisible forces shaping the galaxy. The Milky Way has cannibalized many smaller galaxies throughout its history. Evidence of these ancient mergers exists in streams of stars that crisscross the galactic halo. One such stream, called the Sagittarius Stream, comes from the Sagittarius dwarf elliptical galaxy, which is currently being torn apart by the Milky Way's gravity. As the smaller galaxy orbits, tidal forces stretch it into a long stream of stars wrapping around the Milky Way. The Gaia mission, which has measured the precise motions of over 1 billion stars, has revealed many such streams, each the remnant of a dwarf galaxy consumed long ago. These streams are like fossils in the sky, preserving evidence of the Milky Way's violent past. Our galaxy grew by eating its neighbors, and this process continues today. Let's pause here and take a deep breath together. Every atom in your body, the carbon, the nitrogen, the oxygen, the iron, was created in the core of a dying star. The ground beneath you, the air you breathe, the water you drink, all born from stellar fire billions of years ago. Feel yourself carrying the trace of ancient stars. You are not separate from the galaxy. You are part of it, made from it. Return to it, always. We are all travelers through space, riding on a small planet through the spiral arms. Now we continue our journey. The center of the Milky Way is one of the most extreme environments in the galaxy. Millions of stars orbit within a few light years of Sagittarius A star, packed far more densely than in our neighborhood. Radiation levels are intense. Stellar winds from massive stars collide and create shock waves. And the supermassive black hole, though relatively quiet now, occasionally flares when gas clouds wander too close. Astronomers have observed stars called S stars orbiting extremely close to Sagittarius A star, completing orbits in just a few years or decades. One star, S2, orbits so close that it reaches speeds up to 3%, the speed of light, at its closest approach. By tracking these stars' orbits with incredible precision, astronomers confirmed the black hole's mass and provided tests of Einstein's general relativity in the strongest gravitational field yet observed. The Milky Way contains exotic objects called neutron stars, the collapsed cores of massive stars that exploded as supernovae. A neutron star packs about 1.4 times the Sun's mass into a sphere only about 20 kilometers across, roughly the size of a city. A sugar cube-sized amount of neutron star material would weigh about 1 billion tons on Earth. These objects have the strongest magnetic fields in the universe, up to 1 trillion times stronger than Earth's magnetic field. Some neutron stars, called pulsars, spin rapidly and emit beams of radiation from their magnetic poles. As the star rotates, these beams sweep across space like a lighthouse beam, and if Earth lies in the path, we detect regular pulses of radio waves. The Milky Way contains thousands of known pulsars, cosmic clocks keeping time with extraordinary precision. Star clusters come in 2 types: open clusters and globular clusters. Open clusters are loose collections of a few dozen to a few thousand young stars, born together from the same molecular cloud. Because they're loosely bound, gravitational interactions with other objects gradually disperse them over hundreds of millions of years. The Pleiades, visible to the naked eye, is a famous open cluster about 100 million years old. Globular clusters, as mentioned earlier, are much older, denser, and more tightly bound. They survive for billions of years. Our Sun likely formed in an open cluster billions of ago, but the cluster has long since dispersed, its members scattered across the galaxy. The stars that formed alongside the Sun now orbit far apart, siblings separated by time and space, never to reunite. The Milky Way hosts stellar remnants called white dwarfs, the final state of stars like the Sun after they've exhausted their nuclear fuel. When a star runs out of hydrogen to fuse, it expands into a red giant, then sheds its outer layers, leaving behind a hot, dense core, a white dwarf. This remnant is no longer fusing elements. It simply radiates away its residual heat over billions of years, gradually cooling and fading. White dwarfs are incredibly dense. A white dwarf with the mass of the Sun would be only about the size of Earth. Eventually, after countless billions of years, longer than the current age of the universe, white dwarfs will cool completely, becoming black dwarfs, dark cinders drifting through space. But the universe isn't old enough yet for any black dwarfs to exist. The Milky Way is filled with something called cosmic rays, high-energy particles, mostly protons, traveling through space at nearly the speed of light. Despite their name, cosmic rays aren't rays at all. They're particles. They originate from supernovae, pulsars, and other energetic events, accelerated to tremendous speeds by shock waves and magnetic fields. When cosmic rays strike Earth's atmosphere, they collide with atoms, creating showers of secondary particles. Some of these particles reach the ground, passing through buildings, through you, constantly. Right now, as you listen, countless cosmic rays are streaming through your body, most causing no harm. They're a reminder that space isn't empty or passive. It's alive with radiation, particles, and energy, all products of the violent processes occurring throughout the galaxy. The Milky Way contains stellar black holes, formed when massive stars, those with more than about 20 times the Sun's mass, collapse at the end of their lives. Unlike supermassive black holes like Sagittarius A star, stellar black holes are much smaller, typically just a few dozen times the Sun's mass. They're invisible, but astronomers detect them through their gravitational effects on nearby stars. In a binary system where a black hole orbits a visible star, gas from the companion star can spiral into the black hole, forming an accretion disk that heats up and emits X-rays. The Milky Way likely contains millions of stellar black holes, most invisible and undetected, silently orbiting through the galaxy. Each one is a collapsed star, a region of space-time so warped that nothing can escape. The galaxy's interstellar medium isn't just gas. It contains tiny, solid particles called dust grains. These grains are microscopic, typically less than a micrometer across, smaller than the width of a human hair. They're composed of elements like carbon, silicon, oxygen, and iron, forged in stars and expelled into space. Though individually tiny, dust grains collectively absorb and scatter starlight, making distant objects appear dimmer and redder, a phenomenon called interstellar extinction. Dust also plays a crucial role in star formation. The surfaces of dust grains provide places for atoms and molecules to meet and bond, allowing complex chemistry to occur in the cold interstellar environment. Without dust, the universe would look very different, and the processes leading to planet formation and possibly life might never occur. Binary stars are extremely common in the Milky Way. Rather than being solitary like the Sun, most stars exist in systems of two or more gravitationally bound companions. These stars orbit a common center of mass, locked in an eternal dance. Some binaries are so close that they exchange material, with gas from one star flowing onto the other. Others are widely separated, orbiting at distances where their interaction is minimal. Binary systems provide natural laboratories for studying stellar physics. By measuring their orbital periods and separations, astronomers can calculate their masses, one of the most important properties of a star. The Sun's solitary nature is somewhat unusual. If you could visit a random star in the galaxy, you'd more likely find it accompanied by at least one companion. The Milky Way rotates in a specific direction, and nearly all its stars orbit in roughly the same plane and direction. This orderly motion is a leftover from the galaxy's formation. When the rotating cloud of gas collapsed to form the galaxy, angular momentum caused the material to settle into a spinning disk. Think of how water swirling down a drain forms a vortex. The galaxy's rotation is similar, though much slower and on a vastly larger scale. However, not everything follows this pattern. Some stars have highly elliptical or even retrograde orbits, moving opposite the majority. These oddballs are often captured from smaller galaxies or disturbed by gravitational interactions. The overall motion is orderly, but individual exceptions remind us that the galaxy's history is complex and dynamic. The Milky Way's spiral arms are regions of active star formation because they're where gas clouds collide and compress. As material moves through a density wave, it slows down and piles up, increasing the local density. This compression triggers the collapse of molecular clouds, leading to bursts of star formation. Massive, hot, blue stars, those that live fast and die young, are especially common in spiral arms. These stars are so luminous they dominate the light from the arms, making the spirals appear bright and blue in photographs. By contrast, the regions between the arms contain more older, cooler, redder stars. The spiral pattern you see in images of galaxies isn't just a structure, it's a story of ongoing starbirth, marked by the brilliant light of youth. When massive stars complete their lives, they transform in a process called supernova, a brilliant finale that enriches the galaxy. The star's outer layers drift outward into space, carrying newly formed elements with them, enriching the interstellar medium with heavy elements synthesized during the star's life and in the transformation itself. These elements, carbon, oxygen, silicon, iron, and more, become part of new clouds, new stars, new planets. Supernovae also create shock waves that compress nearby gas, triggering new waves of star formation. The Milky Way experiences a few supernovae per century, though many are hidden by dust and go unobserved from Earth. Each supernova is both an ending and a beginning, scattering the ingredients for future generations of stars and worlds. The Milky Way is home to planets beyond counting. Our solar system contains 8 planets, but most stars in the galaxy likely host planets as well. Data from NASA's Kepler mission, which monitored over 150,000 stars, revealed that planets are common. There may be more planets than stars in the Milky Way. Estimates suggest hundreds of billions of planets exist in our galaxy alone. Some are gas giants larger than Jupiter, others are rocky worlds like Earth, and many are types that don't exist in our solar system. Some orbit in habitable zones where liquid water could exist. The question isn't whether planets exist elsewhere, but whether any harbor life. We live in a galaxy teeming with worlds, most of which we've never seen and never will. Each star you see might host its own family of planets. Red giants are stars nearing the end of their lives, having exhausted the hydrogen in their cores. As fusion slows, the core contracts and heats up, causing the outer layers to expand dramatically. The star swells to enormous size, sometimes hundreds of times its original diameter, and its surface cools, giving it a reddish color. Eventually, the Sun will become a red giant. In about 5 billion years, it will expand beyond Earth's orbit, engulfing Mercury and Venus and rendering Earth uninhabitable. But this transformation won't happen suddenly. It will unfold over millions of years. Red giants are common in the Milky Way, visible in the night sky as some of the brightest stars. Betelgeuse, for example, is a red supergiant nearing the end of its life, likely to explode as a supernova sometime in the next 100,000 years. The Milky Way contains massive stars that live fast and die young. Stars more than 8 times the Sun's mass burn their nuclear fuel at prodigious rates, shining brilliantly but briefly. While the Sun will live for about 10 billion years, a star 20 times more massive might live only 10 million years, 1,000 times shorter. These massive stars dominate the light output of the galaxy, despite being relatively rare. They're also the engines of cosmic enrichment, synthesizing heavy elements and scattering them through supernova explosions. Without massive stars, the universe would lack the chemical diversity necessary for planets and life. These stars are like fireworks, spectacular, intense, and brief. They light up the galaxy for a fleeting moment in cosmic time, then vanish, leaving behind neutron stars or black holes. Molecular clouds, the birthplaces of stars, can be enormous. The largest, called giant molecular clouds, contain hundreds of thousands or even millions of times the Sun's mass in gas and dust. These clouds are vast, spanning hundreds of light years across, and they're cold, just 10 to 20 degrees above absolute zero. Within these frigid environments, gravity slowly pulls material together. Dense regions within the cloud, called clumps and cores, fragment and collapse, each forming one or more stars. Star formation is inefficient. Only about 1 to 10% of a cloud's mass actually becomes stars. The rest is either dispersed by stellar winds and radiation from newly formed stars or remains as diffuse gas. These clouds are the wombs of the galaxy, hidden factories where the future is quietly being assembled. You're still here, still awake, still drifting with us through these stories. Take a slow breath. Notice how your body feels a little lighter now, as if gravity itself has loosened its grip just slightly. We're traveling through space together, you and I, and everyone listening in the quiet dark, floating through facts like asteroids, drifting through the void. There's no rush, no destination, just the gentle momentum of curiosity carrying us forward. Let's continue. The Milky Way's halo contains ancient stars and globular clusters, but it also contains dark matter. Though we don't know what dark matter is made of, it doesn't interact with light, so it remains invisible. The leading candidates are exotic subatomic particles that have never been detected in laboratories, or perhaps primordial black holes formed in the early universe. Despite decades of searching, dark matter remains elusive, yet its effects are undeniable. The motions of stars and gas, the bending of light around massive objects, the structure of galaxy clusters, all require dark matter's gravitational influence. Understanding dark matter is one of the great quests in modern physics. The Milky Way, like all galaxies, is embedded in a halo of this mysterious substance, its nature still hidden from us. The Milky Way and Andromeda are the two dominant members of the local group, and their future remains uncertain. Recent research suggests that if they do eventually merge over the next several billion years, the resulting galaxy would likely become a giant elliptical galaxy, sometimes nicknamed Milkomeda or Milkdromeda. The spiral structure we know would be gone, replaced by a more chaotic, football-shaped distribution of stars. The night sky from Earth, or whatever remains of it, would be unrecognizable. But even if such a merger occurs, it wouldn't be destructive for individual stars. The distances between stars are so vast that collisions will be extremely rare. Stars will simply have new orbits in a new galaxy. This is one possible future of our cosmic neighborhood: transformation, merger, and a new identity formed from two ancient spirals. The galactic bulge, the dense central region of the Milky Way surrounding the supermassive black hole, contains some of the galaxy's oldest stars. This region is roughly spherical, with stars orbiting in random directions rather than in the orderly pattern of the disk. The bulge likely formed early in the galaxy's history, perhaps from mergers with smaller galaxies or from gas that collapsed toward the center. Stars in the bulge are older, on average, than those in the disk, and their orbits are more chaotic. The bulge is also a crowded place. Stars are much closer together than in our neighborhood, making the night sky from a planet there spectacularly bright. The bulge represents the galaxy's deep past, a remnant of its formation preserved at the core. The Milky Way's magnetic field is generated by the motion of charged particles in the galaxy, particularly in the ionized gas of the interstellar medium. This process, called a dynamo, works similarly to how Earth's magnetic field is generated by the motion of molten iron in the planet's core. The galactic dynamo is powered by the rotation of the galaxy and turbulence in the gas. The resulting magnetic field is weak but extensive, threading through the entire galaxy. It influences the paths of cosmic rays, provides support to molecular clouds, and plays a role in the dynamics of gas and star formation. Mapping this field requires sophisticated observations, but its existence is crucial to understanding how the galaxy works. Brown dwarfs are objects that straddle the line between planets and stars. They form like stars from collapsing clouds of gas, but they never accumulate enough mass to sustain hydrogen fusion in their cores. As a result, they don't shine brightly like true stars. They simply radiate away their initial heat, glowing faintly in infrared. Brown dwarfs have masses between about 13 and 80 times that of Jupiter. Below 13 Jupiter masses, they can't even fuse deuterium, a heavier isotope of hydrogen. The Milky Way contains billions of brown dwarfs, dim and difficult to detect, lurking in the darkness between the stars. They're failed stars, forever denied the brilliance of fusion, but they're important for understanding the lower limits of star formation. The Milky Way's spiral structure is influenced by its interactions with other galaxies. The Large and Small Magellanic Clouds, two dwarf galaxies orbiting the Milky Way, are slowly being pulled apart by tidal forces. As they orbit, they leave behind streams of gas that stretch across the sky, called the Magellanic Stream. This gas eventually falls back into the Milky Way, providing fresh material for future star formation. Gravitational interactions with these smaller galaxies may also help maintain or perturb the Milky Way's spiral arms. Galaxies don't exist in isolation. They interact, merge, exchange material, and influence each other's evolution. The Milky Way's structure today is shaped not only by its own internal dynamics, but also by its relationships with its neighbors. Interstellar space is not a perfect vacuum. Though incredibly empty by terrestrial standards, it contains roughly 1 atom per cubic centimeter on average, far more rarefied than the best vacuum we can create on Earth, but not truly empty. This sparse gas is mostly hydrogen, with smaller amounts of helium and trace amounts of heavier elements. In denser regions, particularly in molecular clouds, the density can reach thousands or even millions of atoms per cubic centimeter. In the voids between clouds, the density drops to just a fraction of an atom per cubic centimeter. This tenuous medium is the canvas on which the galaxy's structure is painted. Stars, planets, and life itself form from this diffuse material, concentrated and transformed by gravity. The speed of light is the ultimate cosmic speed limit, and nothing with mass can reach it. Light from the galactic center takes 27,000 years to reach us, and light from Andromeda takes 2.5 million years. These vast distances mean we always observe the universe as it was in the past, never as it is right now. When you look at a star 100 light-years away, you're seeing light that left that star a century ago. If that star exploded yesterday, you wouldn't know for another 100 years. The night sky is a time machine, showing us the past layered at different depths. The farther we look into space, the farther back in time we see. The universe is not just vast in space, but in time as well. The Sun is an ordinary star, neither particularly large nor small, hot nor cool, young nor old. It's a middle-aged, medium-sized star, a yellow dwarf in the main sequence phase of its life. This ordinariness is actually reassuring. It means that billions of similar stars exist in the Milky Way, and if life arose around our ordinary star, perhaps it has arisen elsewhere around other ordinary stars. The Sun has been shining steadily for about 4.6 billion years and will continue for another 5 billion before it exhausts its hydrogen fuel. In the grand scheme of the galaxy, the Sun is unremarkable, but to us, it's everything, the source of light, warmth, and energy that makes life on Earth possible. From our perspective, it's the most important star in the universe. Halfway through our journey now, we've traveled from the galactic center outward through the spiral arms, encountering black holes, neutron stars, star clusters, dust clouds, and planets. The Milky Way is vast and ancient, and yet it's just one galaxy among hundreds of billions in the observable universe. Each galaxy has its own story, its own structure, its own populations of stars and planets. The universe is almost unimaginably large, but scale isn't the only thing that matters. What's remarkable is that we, small creatures on a small planet orbiting an ordinary star, have figured out so much about the cosmos. We've measured the galaxy's size, mapped its structure, discovered its history. Curiosity and patience have carried us far, and there's still so much more to explore. Let's pause again, together, and imagine, even when everything seems empty, space is always full of waves, vibrations, invisible energy. The space inside and around you is never truly empty. Think of time, moving differently here on Earth than near the galactic center. Time bends with gravity. Time stretches with speed. Your second here is unique, yours alone. And while the vast universe continues to spin, expand, change, this second you're breathing, listening, is unique. Imagine you're floating on a calm lake, but beneath the surface, there's always gentle current. Now, we continue the journey. Stellar winds are streams of charged particles flowing outward from stars. The Sun has a solar wind that extends far beyond the planets, creating a bubble called the heliosphere. Massive stars have even stronger winds, losing significant mass over their lifetimes. These winds carry energy and momentum into space, heating the interstellar medium and driving material away from star-forming regions. Stellar winds shape nebulae, create bubbles and shells in the interstellar gas, and influence the evolution of nearby clouds. They're invisible but powerful, constantly flowing outward, pushing against the surrounding space. The Milky Way is filled with these winds, overlapping and interacting, creating a dynamic, turbulent environment, far from the stillness we imagine when we think of space. Planetary nebulae are glowing clouds of gas ejected by dying stars. Despite their name, they have nothing to do with planets. They were named centuries ago because they appeared round and planet-like through early telescopes. When a sun-like star exhausts its fuel, it sheds its outer layers in a gentle explosion, and the exposed core, now a hot white dwarf, illuminates the expanding shell with ultraviolet light, causing it to glow. Planetary nebulae come in a variety of shapes: spherical, ring-shaped, bipolar, and more complex forms. They last only a few tens of thousands of years before dispersing into space, returning enriched material to the interstellar medium. They're beautiful, brief, and a glimpse of the Sun's distant future. The Milky Way has a warp. The galactic disk isn't perfectly flat. It bends and twists at the edges, particularly in the outer regions. Recent data from the Gaia mission confirmed this warping, creating a three-dimensional map of the disk's shape. The warp likely results from gravitational interactions with satellite galaxies, or from the torque exerted by the Milky Way's dark matter halo. The disk wobbles and bends like a vinyl record that's been left in the sun too long. This warping doesn't affect the inner galaxy much, but at the outskirts, the disk tilts significantly above and below the main plane. It's a reminder that the Milky Way isn't a perfect, static structure. It's dynamic, flexible, and shaped by forces acting over billions of years. Some stars are ejected from the Milky Way entirely, flung outward at high speeds by gravitational interactions. These hypervelocity stars travel faster than the galaxy's escape velocity, meaning they'll never return. They were likely accelerated by close encounters with binary stars near the galactic center, or by interactions with the supermassive black hole itself. Once launched, they coast through intergalactic space, destined to wander the void between galaxies for billions of years. Astronomers have identified dozens of these runaway stars, and likely many more exist undetected. They're orphans, exiles from the galaxy, carrying with them a reminder that gravitational interactions can sometimes be violent enough to tear apart even ancient orbital relationships. The Milky Way's rotation isn't uniform. Different parts rotate at different speeds. Near the center, stars orbit faster, completing circuits in just a few million years. Farther out, in the disk where we are, orbital periods stretch to hundreds of millions of years. This differential rotation creates shear, stretching and winding the magnetic field, driving turbulence in the gas. It also means that structures in the galaxy don't rotate as solid bodies. The spiral arms, the bar, the gas clouds, all these features have their own patterns of motion. The galaxy is less like a spinning wheel and more like a swirling fluid, with currents, eddies, and flows interacting in complex ways. Variable stars change in brightness over time. Some, like Cepheid variables, pulsate regularly, expanding and contracting as their internal pressure and gravity battle for balance. Others, like eclipsing binaries, dim when one star passes in front of the other, as seen from Earth. Cepheid variables are particularly important. Their pulsation periods are directly related to their luminosity, making them standard candles for measuring cosmic distances. By observing Cepheids in other galaxies, astronomers can determine how far away those galaxies are. This technique, pioneered by Henrietta Swan Leavitt and used by Edwin Hubble, helped reveal the universe's true scale. The Milky Way contains thousands of variable stars, each one a beacon that changes with clockwork regularity. The Milky Way's oldest stars are metal-poor, meaning they contain very few elements heavier than hydrogen and helium. They formed when the galaxy was young, before many generations of stars had lived and died to enrich the interstellar medium. These ancient stars are living fossils, preserving information about the early universe. By studying their compositions and motions, astronomers learn about the conditions that existed billions of years ago. Some of these stars are nearly as old as the universe itself, over 13 billion years. They've witnessed the entire history of the galaxy, silently orbiting, surviving supernovae, mergers, and countless cosmic events. They connect us to the distant past, a time when the galaxy was just beginning. The interstellar medium contains complex organic molecules, compounds made of carbon, hydrogen, oxygen, nitrogen, and other elements. These molecules form on the surfaces of dust grains in molecular clouds, where atoms and simple molecules collide and stick together. Over time, they build up into more complex structures, including amino acids, the building blocks of proteins. These organic molecules are found throughout the Milky Way, and they're delivered to planets via comets and asteroids. Some scientists believe that life on Earth may have been seeded partly by organic material from space. The galaxy is, in a sense, a vast chemistry lab, producing the precursors of life and distributing them throughout the cosmos. The Milky Way's gravitational influence extends far beyond the visible disk. Satellite galaxies orbit the Milky Way at distances of hundreds of thousands of light-years. The large and small Magellanic Clouds, visible from the southern hemisphere, are the most famous. There are also dozens of much smaller, fainter dwarf galaxies, some discovered only in recent years. These satellites are bound to the Milky Way by gravity, slowly orbiting, and eventually many will merge with the larger galaxy. They're the last remnants of the galaxy-building process. Small galaxies that avoided being absorbed earlier. Their presence reminds us that the Milky Way isn't just a spiral disk. It's a system, surrounded by a family of smaller companions. Light pollution on Earth prevents most people from seeing the Milky Way. A century ago, the night sky was dark almost everywhere, and the Milky Way was a common sight. Today, artificial light floods the night, washing out the stars. In cities, only the brightest stars and planets are visible. To see the Milky Way's full glory, you need to travel far from urban centers, to deserts, mountains, or remote countryside. There, under truly dark skies, the Milky Way appears as a glowing river arching overhead, densely packed with stars, nebulae, and dust lanes. It's worth the journey. Seeing the galaxy with your own eyes connects you to something vast and ancient, a reminder of our place in the cosmos. The Milky Way will eventually run out of gas. Star formation requires cold molecular gas, and while the galaxy still has substantial reserves, that supply is finite. Each generation of stars locks up material in long-lived stars, white dwarfs, neutron stars, and black holes. Some gas is ejected by stellar winds and supernovae, escaping the galaxy entirely. The infall of fresh gas from the intergalactic medium and from satellite galaxies replenishes the supply somewhat, but eventually, the balance will shift. In tens of billions of years, the Milky Way will form its last stars. After that, the galaxy will slowly fade as the remaining stars age and die, leaving behind a cold, dark collection of stellar remnants. The age of stars will end. Gravity holds the galaxy together, but it also shapes its structure. The gravitational pull of the central bulge and dark matter halo keeps stars in orbit. Gravitational interactions between stars, gas clouds, and dark matter create the spiral pattern, the bar, and the warps in the disk. Gravity is universal, affecting everything equally, from the smallest dust grain to the largest galaxy cluster. It's the sculptor of the cosmos, patient and relentless, shaping structures over billions of years. Without gravity, the Milky Way would disperse into a formless cloud. Gravity is the silent architect, invisible yet all-powerful, binding the galaxy into a coherent, organized system. It's the force that makes galaxies possible. The Milky Way's spiral arms are named after the constellations they pass through as seen from Earth. The Perseus arm, the Sagittarius arm, the Scutum Centaurus arm, each named for its apparent position on the sky. But remember, constellations are arbitrary patterns of stars at vastly different distances. The arms themselves are physical structures, regions of higher density stretching thousands of light years through the galactic disk. The names are human creations, convenient labels for features we can't see directly but have inferred from observations. It's a reminder that much of astronomy involves indirect evidence, clever reasoning, and patience. We map the Milky Way not by visiting it, but by carefully observing and interpreting the light that reaches us. The Sun's orbit around the galaxy isn't a perfect circle. It's slightly elliptical, like most orbits. This means the Sun's distance from the galactic center varies over the course of its 225 million-year orbit. At times, it's a bit closer. At other times, a bit farther. These variations are small, only a few percent, but they change the Sun's environment. When closer to the spiral arms, the solar system encounters denser regions of gas and dust, possibly increasing the rate of comet impacts on Earth. When farther away, the environment is quieter. These changes happen slowly, over millions of years, but they subtly influence the conditions in our corner of space. We're not in a fixed position. We're travelers. The Milky Way's history is written in its stars. By measuring the ages, compositions, and motions of stars, astronomers piece together the galaxy's past. Old, metal-poor stars in the halo tell us about the early galaxy. Younger, metal-rich stars in the disk reveal more recent history. Streams of stars mark ancient mergers. Globular clusters preserve snapshots of specific epochs. This field, called galactic archaeology, treats the Milky Way as an archaeological site, where clues are scattered throughout space rather than buried in the ground. Each star is a data point, a piece of the puzzle. Together, they reveal a story of formation, growth, mergers, and transformation spanning over 13 billion years. The Milky Way contains strange objects we still don't fully understand. Magnetars are neutron stars, with magnetic fields 1,000 trillion times stronger than Earth's. Quark stars, if they exist, might be even denser than neutron stars, composed of exotic matter. Primordial black holes, formed in the early universe rather than from stellar collapse, might lurk unseen in the galaxy. Dark matter particles, whatever they are, fill the halo. The universe is full of mysteries, and the Milky Way is no exception. Every answered question reveals new puzzles. We've learned so much, but the galaxy still holds secrets, phenomena that challenge our understanding and push the boundaries of physics. Star clusters gradually dissolve over time. Gravitational interactions with other stars and gas clouds perturb the orbits of cluster members. Some stars gain energy and escape, others lose energy and sink toward the center. Over hundreds of millions of years, open clusters disperse completely, their stars scattered across the galaxy. Globular clusters, being much denser and more massive, survive longer, but even they slowly lose stars. The Milky Way's star clusters are transient features, born, evolving, and eventually dissolving. Yet new clusters form constantly from molecular clouds, so the galaxy always contains a mix of young, middle-aged, and old clusters. It's a cycle of birth and dispersal, repeated endlessly. The Milky Way is not alone in experiencing mergers. Most large galaxies have grown through cannibalism, absorbing smaller neighbors over billions of years. Mergers can be violent, triggering bursts of star formation as gas clouds collide, or they can be gentle, with the smaller galaxy slowly dissolving into the larger one. The Milky Way's smooth spiral structure suggests it hasn't experienced a major merger recently, at least not in the last few billion years. But the evidence of past mergers exists in stellar streams, in the orbits of halo stars, and in the ages of globular clusters. The galaxy we see today is an amalgamation, a fusion of many smaller systems combined over time. The night sky from a planet near the galactic center would be extraordinary. Thousands of stars would be visible, many close enough to cast shadows. The sky would never be truly dark. Nebulae would glow vividly, illuminated by intense radiation. But life near the galactic center would face challenges. Radiation levels are high, stellar encounters are frequent, and the environment is chaotic. Our position in the quiet suburbs seems almost ideal. We're far enough from the chaos to enjoy stability, but close enough to witness the galaxy's grandeur. The night sky is a balance, dark enough to show the stars, but populated enough to inspire wonder. We live in a Goldilocks zone, cosmically speaking. If the Milky Way and Andromeda do eventually merge, what happens to the stars? Most will simply move into new orbits. The Sun will likely end up somewhere in the outer regions of the merged galaxy, perhaps farther from the center than it is now. Earth, if it still exists, will have a new sky, the stars rearranged, new constellations, and Andromeda's stars mixed with ours. But by that time, the Sun will be a red giant, and Earth will be uninhabitable or destroyed. The potential merger is the galaxy's future, but it's not ours. Our story will end long before the galaxies might meet. But the material we're made from will continue, recycled into new stars, new planets. The Milky Way rotates once every 225 to 250 million years at the Sun's location. This period is sometimes called a galactic year. During one galactic year, entire ecosystems on Earth have risen and fallen. The continents have shifted. Life has evolved from one form to another. Extinctions have occurred. Ice ages have come and gone. And the Sun has quietly completed another orbit, returning to roughly the same position. Time on galactic scales makes human history feel brief. Geological time feels short. Yet, this perspective is humbling. We're part of something vast and slow. A grand cosmic dance that's been unfolding for billions of years and will continue for billions more. The Milky Way's beauty is partly due to dust. Dust obscures light, creating dark lanes against the glowing backdrop of stars. These dark regions aren't empty. They're dense clouds where stars are forming. Dust also scatters and reflects light, creating nebulae that glow in beautiful colors. Without dust, the galaxy would look different, less structured, less varied. Dust is often seen as an obstacle in astronomy, blocking our view, but it's also essential to the processes that create stars and planets. It's both nuisance and necessity. The dark patches in the Milky Way remind us that even the voids contain richness, potential, and hidden activity. Astronomers study the Milky Way using every part of the electromagnetic spectrum: radio waves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Each wavelength reveals different aspects. Radio waves penetrate dust, revealing molecular clouds and the galactic center. Infrared shows cool stars and dust. Visible light captures the familiar glow of stars. Ultraviolet highlights hot, young stars. X-rays reveal neutron stars, black holes, and supernovae remnants. Gamma rays trace the most energetic processes. Together, these observations create a complete picture. The Milky Way isn't just one image. It's a symphony of data across wavelengths, each contributing unique information. Understanding the galaxy requires seeing it in every possible way. The galaxy is quieter now than it was in its youth. Billions of years ago, star formation rates were much higher. Gas was abundant, mergers were frequent, and the galaxy was more turbulent. As the universe aged, star formation slowed. Today, the Milky Way forms only a few new stars per year, far fewer than in its early days. This quieting is natural. Galaxies evolve from chaotic youth to calmer maturity. Eventually, as gas runs out, the galaxy will become quieter still. But for now, it remains active, still forming stars, still evolving, still dynamic. We live during a relatively peaceful era in the galaxy's long life. The Milky Way is our home, but it's temporary. On cosmic timescales, nothing is permanent. Stars are born and die. Galaxies merge and transform. Even the universe itself will change as it expands and ages. But for now, for the span of human civilization and far beyond, the Milky Way is constant. It arches across our night sky, a reminder of the vastness beyond Earth. It contains our past, the stars that created our elements, and our future, whatever that may be. We're part of the galaxy, and it's part of us. We share a history written in starlight and time, spanning billions of years. You might be feeling tired now. That's perfectly fine. Breathe slowly. Feel the cycles. Stars are born, stars die. Galaxies collide, galaxies merge. All are circles, cycles, endless orbits. Like your breath, inhale, exhale, inhale, exhale. A small cycle within the vast universe. You are also part of that eternal movement. You don't need to hold on to anything. Let everything unfold in its perfect order, like planets silently rotating in their orbits, unhurried, unresisting, simply existing. We're almost there now. The Milky Way is just one galaxy in a universe containing hundreds of billions. Each galaxy is unique, with its own shape, size, history. Some are spirals like ours, others are elliptical, irregular, or peculiar. Each galaxy contains billions of stars, and each star might host planets. The scale is almost beyond comprehension. Yet here we are, on one planet, orbiting one star, in one galaxy among countless others. Our existence is statistically improbable, yet empirically real. We're rare, perhaps even unique. Or perhaps life is common, scattered throughout the cosmos. Either way, we're part of something vast and mysterious. The light from distant stars takes years to reach us. When you look at the night sky, you're seeing the past. Some stars you see might have already died, their light still traveling through space toward Earth. The star Betelgeuse, for example, is about 650 light-years away. If it exploded today, we wouldn't know for 650 years. The universe is not just spread out in space, but also in time. Every photon carries history. The night sky is a time capsule, preserving moments from different eras, all arriving together at your eyes. The Milky Way spins slowly. At our location, the orbital speed is about 220 kilometers per second. That sounds fast, nearly 500,000 miles per hour. But the galaxy is so large that one full orbit takes over 200 million years. Speed is relative. What seems fast on small scales becomes slow on large ones. Patience is built into the cosmos. Changes happen, but slowly, gently, over timescales that dwarf human lifetimes. The universe operates on its own schedule, indifferent to hurry. There's comfort in that slowness, a reminder to let things unfold at their own pace. Dark matter holds the galaxy together, yet we've never seen it directly. It doesn't emit light, doesn't absorb light, doesn't interact with ordinary matter except through gravity. It's invisible, intangible, yet essential. Without it, the Milky Way would fly apart. It's a humbling thought. Most of the galaxy is made of something we don't understand. We see the effects, but not the cause. It's a reminder that the universe still holds mysteries, things beyond our current grasp, and that's okay. Mystery keeps us curious, keeps us searching, keeps us humble. Every star is a sun, potentially with its own family of planets. When you look at the night sky, you're seeing thousands of suns, each a world unto itself. Some might host planets with oceans, mountains, weather. Some might harbor life. Or perhaps Earth is unique, the only place where life arose. We don't know yet, but either answer is profound. If life is common, we're part of a cosmic community. If life is rare, we're precious beyond measure. Either way, existence is miraculous. Stars are born from clouds, live for billions of years, then return to clouds when they die. It's a cycle, endlessly repeated. The matter in the universe doesn't disappear. It transforms, rearranges, becomes something new. You are made of recycled star matter. The atoms in your body have existed for billions of years, passing through stars, clouds, planets, perhaps even other living beings. You're a temporary arrangement of ancient atoms, briefly conscious, briefly aware. Then, those atoms will move on, becoming part of something else. The cycle continues. The Milky Way has been here long before humans existed and will remain long after we're gone. Our civilizations, our histories, our struggles and triumphs all happen in the blink of an eye on galactic timescales. This perspective can feel diminishing, but it can also be freeing. Our worries are temporary, our troubles finite. The galaxy continues its slow rotation, indifferent to our dramas. There's peace in that indifference. It's a reminder that in the grand scheme, it's okay to let go, to relax, to trust that the universe will unfold as it should. The spiral arms of the Milky Way are waves of density moving through the disk, causing stars and gas to bunch up temporarily. Stars enter an arm, slow down, then leave. They don't stay in one place. Nothing in the galaxy is fixed. Everything flows, everything moves, everything changes. Permanence is an illusion, but that's not frightening. It's liberating. If everything changes, then difficult moments will pass. Hard times are temporary. The spiral pattern persists even as individual stars move through it. Similarly, patterns in your life persist even as moments pass. The sun is unremarkable, one star among hundreds of billions, yet it's our star. It provides warmth, light, energy. It makes life possible. To the universe, the sun is nothing special. To us, it's everything. Perspective matters. What seems insignificant on one scale is vital on another. Your life might seem small in the cosmic scheme, but it's everything to you, and to those who know you. Scale doesn't determine value. Importance is contextual. You matter in your context, just as the sun matters in ours. Gravity shaped the Milky Way, pulling gas together, forming stars, creating structure. Gravity is patient. It works slowly, over millions of years, shaping galaxies, guiding orbits, holding systems together. It doesn't rush. It simply persists, constant and reliable. There's something calming about that. Forces in the universe operate on their own timelines, unaffected by impatience. Change happens when it's ready, not when we demand it. Gravity teaches patience. It reminds us that some things take time, and that's okay. Slow change can be profound. When stars die, they create new elements and scatter them into space. Supernovae are violent, but they're also creative. Destruction and creation are linked. Endings lead to beginnings. The death of one star seeds the birth of new stars, new planets, perhaps even new life. Nothing is truly lost, only transformed. This cycle is written into the fabric of the universe. Every ending contains the potential for something new. Death is not the end of matter, only the end of one arrangement. Life moves on, in new forms. The Milky Way's black hole, Sagittarius A star, sits quietly at the center, massive yet gentle. It doesn't devour everything nearby. Most material orbits safely around it. Black holes have a reputation for destruction, but they're just objects, obeying the laws of physics. They don't seek to consume, they simply exist. Fear often comes from misunderstanding. Once understood, black holes are fascinating rather than terrifying. Similarly, things we fear often lose their power when we understand them. Knowledge brings calm. The universe is strange, but it's not malicious. We see the Milky Way as a band of light across the sky, but we're inside it, embedded in the disk. We can't step outside to see the whole structure. We infer the spiral shape from observations, from star positions, from gas distributions. We've never seen our own galaxy from outside, yet we know its shape. Sometimes, perspective comes from patient observation, not direct sight. We piece together the bigger picture from limited views. This is true in life as well. Understanding comes gradually, from many small observations. The Milky Way contains hundreds of billions of stars, but the distances between them are vast. Space is mostly empty. If you shrunk the sun to the size of a grain of sand, the nearest star would be several kilometers away. Emptiness and matter coexist. The galaxy is both full and empty, crowded and lonely. This paradox is comforting. Even in the most crowded places, there's space. Even in the emptiest voids, there's connection. You can be both alone and part of something vast. Both are true. If the Milky Way and Andromeda do eventually merge, it will happen billions of years in the future, unimaginably distant. For now, the galaxy is stable, rotating quietly, forming stars, evolving slowly. The future is uncertain, but the present is calm. Worrying about distant events doesn't change them. The galaxy's potential future transformation will happen on its own schedule, far beyond our influence. Sometimes it's best to focus on the present, accepting that the future will unfold as it will. Letting go of distant worries brings peace. Stars live for billions of years, shining steadily, following predictable paths. Their existence is orderly, governed by physics, reliable. The sun rises every day because it must, because the laws of nature demand it. There's comfort in this reliability. The universe operates according to rules, not chaos. Even when things feel uncertain, the fundamental processes of nature continue unchanged. Gravity pulls, fusion burns, light travels. These constants provide a foundation. The cosmos is orderly, even when your life feels chaotic. Molecular clouds are cold, dark, and quiet. Yet there where stars are born, beginnings often happen in silence, in darkness, in places we can't see. Growth doesn't always announce itself. Stars form slowly, hidden within clouds, and only reveal themselves once they ignite. Patience is required. Not everything is immediate. Some processes take time, unfolding in the dark, invisible until they're ready. Trust the process. Transformation is happening even when you can't see it. The galaxy teaches patience and faith in unseen progress. The Milky Way is ancient, over 13 billion years old. It has witnessed the birth and death of countless stars, the formation of solar systems, the rise and fall of civilizations. It was here long before us and will be here long after. This longevity is humbling. We're brief visitors in a universe that spans eons. Our time is short, but the galaxy continues. There's something peaceful in that, knowing that the larger patterns persist beyond us. We don't have to carry everything. The universe will continue. Light from the galactic center takes 27,000 years to reach us. What we see today happened in the deep past, long before human civilization existed. The universe shows us its history, layer by layer, light from different eras arriving together. The present moment contains echoes of the past. This layering of time is beautiful. Every moment is connected to what came before. We're part of a continuum, linked to the past and future by the flow of time. Nothing is isolated. The stars you see at night are your connection to the galaxy. Each point of light is a sun, possibly with planets, possibly with life. When you look up, you're not just seeing distant objects. You're connecting to a vast community of stars, all part of the same galaxy, all orbiting the same center. You're not alone. You're part of the Milky Way, one small piece of something immense and beautiful. The night sky is a reminder of connection, of belonging to something larger. The Milky Way is shaped like a spiral because of rotation and gravity. These simple forces, acting over billions of years, create intricate patterns. Complexity arises from simplicity. The universe doesn't need complicated rules to create beauty, just gravity, time, and motion. This is reassuring. Complexity isn't always necessary. Sometimes simple principles, applied patiently, create profound results. The spiral shape is elegant because it's natural, arising inevitably from the laws of physics. There's beauty in simplicity and inevitability. The Milky Way rotates, but you don't feel it. The Earth spins. The Earth orbits the Sun orbits the galaxy moves through space. All these motions happen simultaneously, yet you feel nothing. Everything moves together. There's no wind, no sensation. This seamless motion is like being carried by a current. You're always moving, always traveling through space, but it feels like stillness. Sometimes motion and stillness coexist. You can be moving and at peace simultaneously. Every atom in your body was forged in a star. You are, literally, stardust. This isn't metaphor, it's physics. The calcium in your bones, the iron in your blood, the oxygen you breathe, all star-born. You carry the galaxy within you. You're not separate from the cosmos, you're made of it. This connection is profound. You belong to the universe in the most fundamental way possible. You're part of the Milky Way's story, a conscious fragment of the galaxy, aware of itself. The Milky Way is home, not just Earth, but the entire galaxy. Our solar system is one small part of a vast structure, and that structure is our cosmic neighborhood. When you look at the night sky, you're looking at home from the inside. The stars aren't distant strangers, they're neighbors, fellow members of the galactic community. This perspective shifts how we see ourselves. We're not isolated. We're part of something ancient, vast, and beautiful. We belong here. The Milky Way will continue long after we're gone, spinning slowly through space, forming stars, evolving, eventually merging with Andromeda. The galaxy's story is far from over, but your part in that story is now. You exist in this moment, under these stars, breathing this air, alive and aware. This moment is yours. The galaxy doesn't need you to understand it completely, or to worry about its future. It simply invites you to witness it, to appreciate it, and then to rest. And so, our quiet journey through the Milky Way comes to a gentle close. We've traveled from the supermassive black hole at the galaxy's heart to the spiral arms stretching across the cosmic void, from ancient globular clusters to newborn stars hidden in molecular clouds, discovering along the way that the galaxy is both vast and intimate, ancient and still evolving. From stardust forming in stellar furnaces to planets orbiting distant suns, we've glimpsed how the Milky Way is both our home and our history. You've drifted through facts like stars drifting through the spiral arms, and now it's time to let these thoughts settle, like dust settling in a quiet nebula. The Milky Way reminds us that we're part of something far larger than ourselves, yet intimately connected to it. The atoms in our bodies were created in stars that died billions of years ago. We are, quite literally, made of the galaxy. Much of the universe's most profound work happens in silence. Stars forming in dark clouds, black holes warping space-time, gravity shaping entire galaxies over billions of years. The Milky Way teaches us patience, perspective, and connection. Without the slow work of stellar fusion, without the patient accumulation of matter over eons, we wouldn't exist. By pausing to notice the night sky, we glimpse the extraordinary woven into the fabric of existence. And now, in these final minutes, take the deepest breath you can, as deep as possible. Think about unity of every atom, every star, every galaxy in the universe. Think about the unity of every atom in a black hole, where all boundaries dissolve, light, matter, time, all becoming one. You too can dissolve into sleep like that. No boundaries left between you and rest. Every atom in your body has existed for billions of years. You are ancient. You are stardust. You are the galaxy, aware of itself. Let your entire being dissolve into the gentle darkness, into the soft gravity pulling you into sleep. Prepare for deep sleep. No boundaries left, only peace. Good night. If this gentle journey through the cosmos brought you peace tonight, perhaps share it softly with someone else who's searching for stillness under the stars. It might be exactly what another restless mind needs to finally let go and drift. One quiet share, one peaceful night at a time. But there's no need to do anything now. Nothing at all. You've traveled far tonight, farther than most journeys take you, across 100,000 light-years of spiral arms, through billions of years of galactic history, past black holes and nebulae, through clouds where stars are born. You can allow these thoughts of the Milky Way to fade now, like starlight fading at dawn, leaving only the gentle calm behind. Let your breathing deepen. Let your body feel heavier, as if gravity itself is gently pulling you down into the soft surface beneath you, anchoring you to this moment. If sleep comes, let it carry you like a leaf carried by a slow river, smoothly, inevitably, into a realm where time and weight no longer matter, where thoughts dissolve into dreams, and dreams dissolve into stillness. If your eyes are still open, the next video is waiting for you, ready to continue the journey. But if they're closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, the Milky Way will still be there, rotating silently overhead. Stars will still be forming in distant clouds. The galaxy will still be making its slow, patient journey through space. But tonight belongs to stillness. Tonight belongs to rest. Rest well, fellow traveler of the spiral arms, and remember, you are made of stars. You carry the galaxy within you. You belong to something vast, ancient, and beautiful. Fall asleep to gentle facts, where science meets sleep, Dream deeper with bedtime science. Relax, listen, and drift into sleep. Good night.